Alright guys, there we're going to work with some identities, cofunction, double angle, and half angle identities. You really got to stay with me on this, and we'll battle through them, and we'll make it fine, but just really hang in there. Alright, you need to add these to your sheet. These are called cofunction identities, so stop the video for a minute and copy those down. Basically, they're all pi over 2 minus x. That's important that the order is pi over 2 first minus x. So if you have the sine of pi over 2 minus x, that's always going to be cosine. Cosine pi over 2 minus x is always going to be sine. Tangent pi over 2 minus x is going to be cotangent. Cotangent pi over 2 x is going to be tangent. Secant is going to be cosecant. Cosecant is going to be secant. And I will show you what we'll think about this way. Pi over 2 is really the same thing as 90. So think about sine 30 and cosine 60. They're really the same value because they both add up to be 90, or pi over 2 in radians. That means they're the same. That holds true with tangent, cotangent, and secant, cosecant. That's why they work, because if they add up to be 90 or pi over 2, the angles are the same. All right, we're going to prove this identity. That's pretty much what we're doing today, is we're going to take things and either prove stuff or simplify things. So it says prove this function right here to the left side equals cosine x. So I'm going to do what we did yesterday, the addition. Sine addition, so I'm going to go sine of x cosine pi over 2 plus cosine x sine pi over 2, and just work that out. Sine x is going to stay, cosine pi over 2 is 0, plus cosine x sine pi over 2 is 1. So 0 times anything is 0, cosine x times 1 is cosine x, and there you go. That's all you got to do. You use what we did yesterday to prove that this is true right here, which is what we saw on the last slide. Okay, 2 more to get down. If pi over 2 does not come first, let's say you have x plus or minus pi over 2, or x plus or minus pi over 2, all you get is the opposite. Look what happened to the signs here. Well, with sine, they stayed the same. Sine plus or minus pi over 2 is the same thing as plus or minus cosine. X, however, with the cosine, look what happens. The signs flip, so you got to really be careful there. Signs do flip, so if the x comes first, with the cosine, you got to flip it to get the sine. If x comes first with sine, signs stay the same. All right, find identity for each of the following. So again, we're just going to work this out like we did yesterday. We have tangent of x plus pi over 2. Tangent, same thing as sine over cosine. So I'm going to go with sine of x plus pi over 2 over cosine. Now, I did this because that's what the last slide said. I had the x plus pi over 2. Remember, sine of x plus pi over 2 is just cosine x. Now, this is the weird one. When it was cosine x plus pi over 2, you had to change the sign, make it negative sine x, and that gives you negative cotangent x, because cosine over sine is cotangent. So get the next one real quick. Secant of x minus 90. Secant is reciprocal of cosine, so I'm going to write it that way. 1 over cosine x minus 90. Now remember, 90 degrees is exactly the same thing as pi over 2. And if I do cosine of x minus pi over 2, it's a negative, it's just sine x. 1 over sine x is cosecant x. So that one, all you got to do. All right, last set of identities here. These are called double angle, so make sure you get those down real quick. The weird thing about if there is a weird thing about double angle, actually we got one more. No, this is it. The one weird thing about this, as I was trying to say a second ago, is sine has one thing. Sine of 2x is 2 sine x cosine x. There's one formula for tangent, 2x, but cosine 2x, you have 3 options. And that's basically because of cosine squared minus sine squared is the main one. You can always substitute, remember, 1 minus sine squared for cosine squared, or 1 minus cosine squared for sine squared, and that's what gives you the other 3. Now, I'll show you that in class if you're really interested in knowing where those come from. I'll show that to you. But our basic thing is we're just going to use them to do some things. All right, now let's figure out a couple ways we can use those identities. This first problem says find sine 3 theta in terms of function values of theta. I'm going to change it to x just because it's easier for me to write up here. So I'm going to change sine 3 theta or 3x to 2x plus 1x. And I'm doing that basically because that's what the last slide had on it. We had just had a sine 2x, so I figured it might be good to use it. Good not. Okay, so I'm going to use what we did yesterday with the sine addition. I'm going to go sine 2x cosine x plus cosine 2x sine x. And I'm going to use what I saw on the last slide. Sine 2x was 2 sine x cosine x. times the cosine x that's already there. Cosine 2x, you got 3 options. I'm going to use this one because I got a feeling it's going to help me the most. 2 cosine squared minus 1 times sine x, mainly because I'm already noticing I'm going to have a cosine squared over here in a second. So that gives me a cosine squared here too. So maybe I can combine them. So when I do the multiplication here, I get 2 cosine squared sine x. Over in my next part, I'm going to distribute this sine x through. So I'm going to have 2 cosine squared x sine x. And then sine x minus 1 is just sine x. Right? What I notice is these two are like terms. I can combine those two. It gives me 4 cosine squared x sine x minus sine x. So what I've done, and that's all you have to do, because all it asked me to do is put function values of theta, or x in our case, which meant take the 3x or 3 theta and just turn it into just 1 theta, which is what I did. And even though it looks kind of weird down here, like that looked that simple, it is because there's just a 1 theta or 1x instead of 3. So I'm going to try the second one here that's on this slide. It says cosine cubed in terms of x or 2x. Raise only to the first power, so you got to get rid of the exponent. So cosine cubed. Okay, so cosine cubed is really cosine squared times cosine. And cosine squared, as you know, is really 1 plus cosine 2x over 2. So I'm going to multiply that times cosine x. So when I do that, if I do cosine x times the 1 that's on the top, we get cosine x. If I do cosine x times cosine 2x, now those are different. You really can't multiply those, so you get cosine x cosine 2x over 2. It's not cosine squared on that second one because I have a 2x and a 1x, so it's not the same thing. You're not actually multiplying the same exact value. And that's all you do. We got rid of the cube, which is what they wanted us to do. All right, I think I kind of told you the last set of identities we're at. This is actually the last set. So half angle identities look like this. You need to take a second, add this to your paper, and I'll give you a second to do that. Stop the video, and we'll come back and do a problem right here. Just one more slide after this one. All right, it says simplify each of these, so I'm going to take obviously the first one first, part A. Simplify that as much as we possibly can. Now, one thing I noticed is there's a fraction in the denominator, which I don't like. So one trick you can always do if you have fractions in a fraction is you can multiply your whole numerator and your whole denominator by 2. And what happens is on the top, of course, now it gives me 2 sine x cosine x. In my denominator, the 2 and the 1/2 would cancel, so I just have cosine 2x. Now, one thing I noticed real quick is this right here. 2 sine x cosine x is really the same thing as, I'm writing it wrong already, is really the same thing as sine 2x. That's what sine 2x was. And on the bottom I have cosine 2x, and because they're both 2x's and it's sine over cosine, that is exactly what tangent 2x is, because sine over cosine is tangent. As long as these two values are the same, you can always change it just to tangent. All right, let's tackle this last one here and we'll be done for the day. Okay, let's see here. There it is, and of course it's going to say simplify as much as we can. We have one for x over 2, sine x over 2, and it is this right here. Sine of x over 2 is really the square roots, what we just saw. It's a square root of 1 minus cosine x all over 2. That's not very legible right there, sorry about that. 1 minus cosine x all over 2. And that's squared because sine was squared plus cosine x. Right now, if I square a square root, the square root just goes away. So now I have this. I have really 1 minus cosine x over 2 plus cosine x. That's a 2 down there. And because there's a 2 in the denominator and 2 outside, they just cancel each other, which gives me 1 minus cosine x plus the cosine x that's outside. And you just get 1 right there. I know it's kind of an unusual video, and unusual problems you're not kind of used to seeing. We may spend a day or two working on these to where you get really comfortable, but I promise we'll get there, and we'll be patient, make sure you kind of get it before we move on. So watch this again if you need to, especially after the first time we do it. It'll be great. So I'll see you in class tomorrow.